Assalamualaikum and salam sejahtera. Hi everyone. Before we proceed to our lesson, the first lesson for this semester, I have a question for you. Can you move a can with a balloon? Okay, what is the answer for my previous question? The answer is yes, you can move a can with a balloon. Okay, next, look at this picture. What happened to the boy? Do you have any idea? In order to understand what happened to the boy and also to the can, let's start our first lesson for this semester, lesson 1, and we'll cover chapter 1, which is electrostatic under 1.1 and 1.2. Let's see what is the learning outcome for this lesson 1. We'll cover 1.1 and 1.2. 1.1 under Coulomb's law. State Coulomb's law F equal to KQQ over R square. Sketch the electric force diagram and apply Coulomb's law for a system of point charges. Under 1.2 electric field. Define and use electric field strength E equal to F over Q naught. Use E equal to KQ over R square for point charge. And the last one is C. Sketch the electric field strength diagram. That we will learn under 1.1 and 1.2 for this chapter. Do you know what is electrostatic? Electrostatic is study of electric charges at rest, the forces between them and the electric field associated with them. Electrical charge. Do you know how we can produce electrical charge? Electrical charge can be produced by process of rubbing two materials against each other. And during that process, electrons migrate from one material to another material. We have two types of electrical charges. One is positive charge. Another one is negative charge. Positive charge material is due to the less number of electron over proton, while the negative charge material is due to the more number of electron over proton. One example is when you rub your hands with the comb and then try to attract small pieces of paper, you will find that they are attracted by comb. The small pieces of paper will attracted by the comb. Remember, if you have two electrical charges with the same charge, it will repel to each other. While if you have opposite charges, what happens is two charges will attracted to each other. 1.1 Coulomb's law. 1.1a state Coulomb's law. According to the Coulomb's law, electric force F between 2 point charges is directly proportional to the product of their magnitudes and inversely proportional to the square of the distance separating them. So, here, electric force F, sometimes known as the Coulomb force or electrostatic force. From the statement, we know that electrostatic force or electric force F directly proportional to the product of the 2-point charges. Here I represent by capital Q and Q. Electric force also inversely proportional to the square of the distance that separating the two charges. Okay. Let us imagine that we have two charges separating with the distance r. The first charges is capital Q. The second charge is small q. So from this one, in order to calculate or to find the electrostatic force exerted on each other due to the 2-point charges, we can use this Coulomb's law equation. F equal to K Q over R square, or sometimes we can normally represent both charges as Q1 and Q2. Or we can write the electric force in another form, which is we substitute the K. K represent the proportionality constant or Coulomb constant, which is K itself is 1 over 4 pi epsilon naught. This is K, and we just Q over R squared. So we have two equations. First, F equal to K Q over R square. Another one, we can rewrite this Coulomb force or electric force in another form. Q over 4 pi epsilon naught R square. You can use both equations related to the information given in your question. So, you already know that we use Coulomb's law in order to explain the electrostatic force exerted on each other due to the 2-point charges. Here is the formula in order to calculate the magnitude of the electrostatic force. So, we must know that every single symbol that we use to represent quantity in this equation. So, F here represents the magnitude of electrostatic force, sometimes known as the Coulomb force or electric force. Capital Q and Q here represent the magnitude of charge, or normally we represent with the Q1 and Q2. R is the distance between 2 point charges. K is the proportionality constant of the Coulomb constant, or Coulomb constant, where the value is 9, the power of 9 Newton meter square Coulomb negative 2. C here represent unit of charge, which is coulombs. Epsilon naught is referred to the permittivity of free space, refer to the vacuum or air, and its value is 8.85 10 the power of negative 12 Coulomb square Newton negative 1 meter negative 2. Here are two graphs showing the variation of electrostatic force with the distance between two charges. The first one is graph for F against R, while the second one is the graph for F against 1 over R squared. Instead of this one, you must also know that the unit, SI unit for the charge is Coulomb, represented by capital C. You must also know the definition for 1 Coulomb, which is it's referred to the total charge transferred by a current of 1 ampere in 1 second. And you must know that the sign of the charge can be ignored when substituting into the Coulomb's law equation. Even though electrostatic force is a vector, must have magnitude and also the direction, but the sign notation for the charge have positive charge and negative charge. The positive and negative sign is not represent the direction. The positive and negative represent the properties of the charge. Remember that. Okay. So, the sign of the charge is important in order to distinguish the direction of electric force. We will study it further. So, how we can determine the direction of electrostatic force? Here we have two charges. One is Q1, which is positive charge. Another one is Q2, which negative charge separated by distance R. So, how we want to determine the electrostatic force on each charge due to each other? So, here, they ask you to determine the direction of electrostatic force on charge Q1 due to charge Q2, and also the direction of electrostatic force on charge Q2 due to the charge Q1. So, we must identify two directions of electrostatic force for Q1 and Q2 due to each other. So here, let we see for the first one. They ask to determine the direction of electrostatic force. Okay, highlight this word on which charge? On Q1. So, the direction of electrostatic force for the first one is on Q1. So the direction of electrostatic force will start from the Q1. Either direction is to the right or to the left. The direction of electrostatic force is along the line that joining the two charges. So it cannot be to upwards or downward. So on Q1. So here you look at the both charges. Q1 is positive charge and Q2 is negative charge. So as you know, if the two charges are opposite to each other, it will attract. So here, first starting from the Q1, so direction from Q1, you draw the line. So why the direction of electrostatic force on Q1 is toward the Q2? Because as I mentioned earlier, opposite charge will attract. So the charge 1 is attracted to charge Q2. That's why this is the direction towards the Q2 or to the right. So here, that's the direction. How about the labeling? So here, electrostatic force represented by the capital F. So I will label here as F1, 2. So here I represent with F1, 2. 1, 2 here mean that force on charge 1 due to charge 2. I repeat once again. F1, 2 means that electrostatic force on charge 1 due to charge 2. So, we look for the second one, which is asked to determine the direction of electrostatic force on Q2. So, focus on Q2. So, the direction since Q2 is negative, Q1 is positive, opposite charge. Therefore, Q2 will attracted to Q1 since it's unlike charge or opposite charge. Therefore, D is F21, meaning that electrostatic force on Q2 due to Q1. So, from this diagram, you know that it is attractive force. Okay, so we look another one. So, same here with this previous one, but the difference is only for the charge. if the previous one here, different charges, now the second one is both Q1 and Q2 have the same charge with this separated with the distance r. So, why it repulsive force? So, look here. So, as to determine the direction of force on charge Q1 due to charge Q2 and also to determine the force which is electrostatic force on charge Q2 due to the charge Q1. So here, as I mentioned earlier, focus on this word on Q1. So, this is Q1. Remember that the direction of electrostatic force is along the line that joining the two charges. So, here once again, the direction cannot be upward or downward, either to the left or to the right or towards Q1 or towards Q2 or away from Q1 or away from Q2. Okay, so for the first one on charge Q1. So on Q1. So direction will start from Q1 since both have same charge, so same charge will repel. So if repel, meaning that it must away from the another charge. So that is the direction. So for the labeling, F on 1 due to the charge F1, 2, meaning that force or electrostatic force on charge 1 due to the charge 2. So we look for another one, force on charge Q2 due to the charge Q1. So this is Q2. So the direction of force start from the Q2, but since it's same charge, it will repel, mean it will away from the another charge. So away meaning that this is the direction. So label as F on 2 due 1. So that's how we determine the direction of electrostatic force acted on the charge. So the previous slide just now is actually about how to sketch and draw the electric force diagram and apply Coulomb's law for a system of point charges. So here, a few examples of electric force diagram based on the previous slide. So hopefully you can understand what we have learned from the previous slide. Look a few examples here in order how to solve the problem related to subtopic 1.1. Example 1.1.1, given to you 2-point charges Q1 which is negative 20 nanocoulomb and Q2 90 nanocoulomb are separated by a distance 4 cm as shown in figure below. asks you to find the magnitude and the direction of electric force on Q1 due to Q2. B. The electric force on Q2 due to Q1. And C. Find the electric force on each charge. So, given to you the value of K with Coulomb constant 9.0, 10 the power of 9 Newton meter square Coulomb negative 2. Okay, let me see how we want to handle this type of question. Example 1.1.1 part A. They ask you to find the magnitude and the direction of electric force on Q1 due to Q2. Okay, once again, remember that the electric force sometimes known as this term is equal to the Coulomb force or equal to the electrostatic force. So here, they ask you to find the magnitude of electric force on Q1 due to Q2. So, automatically you know that you must find electrostatic force, which is symbol with F, on Q1 due to Q2. Okay, so generally the equation is F equal to K Q1 Q2 over R square. Remember that the formula is F equal to K, sometimes write with the capital Q, the small q, over R square, or you can use F equal to K Q1 Q2 over R square. Okay. So now, okay, roughly we know that we have two types of charges. One is Q1, which is negatively charged, and then Q2 is positive charge, separated with distance 4 cm. Okay, so the magnitude of the charge Q1 is negative 20 nanocoulomb. Okay, nano is prefix, coulomb is the unit of the charge. And Q2 is 90 nanocoulomb. Okay, so you have value for Q1 and Q2. So you substitute Q1 and Q2 without the sign. Meaning that here Q1 is negative 20 nanocoulomb. Okay, you ignore the sign. The sign here represent the property of the charge, not represent the direction. Okay, clear? Okay, so now here, just substitute K is 9, 10 the power of 9. Q1 is negative 20, but substitute without the sign. So, 20, nano is 10 the power of negative 9. And Q2 is 90, 10 the power of negative 9. Sorry for my bad handwriting. And over distance separated between them is 4 cm. So 4 10 the power of negative 2 square. And then you will get the electrostatic force on charge 1 due to charge 2 is equal to 0.01 Newton. That's the magnitude. But the question is not settled yet because we just do the first part, the magnitude. And how about the direction? Now, we want to determine the direction of electric force on Q1 due to Q2. So, in order to determine the direction, so you must focus at this circle word on Q1. Meaning that now we focus on Q1. So Q1, the direction come out from the Q1. Either it want you moving towards the Q2 or moving away from Q2, depends on the next charge. Okay, next charge here refer to the Q2. So once again, please recall back that in earlier previous slide, I have mentioned about the same charge repel, opposite charge attract. So here we will use that prior knowledge I have tell you. Okay, now we look at the focus on Q1. On Q1. So this is Q1. So negative for Q1. Q1 is negative charge. So another one, Q2 is positive charge. So opposite charge will result Q1 will attracted to Q2. Since Q1 is attracted to Q2, okay, logically the direction of electrostatic force should be like this. Okay. So analogy, if you attracted to somebody or you admire someone, you must get closer to the person. Same with this one. Negative and positive charge is attracted. Therefore, since we focus on Q1, so Q1 must attracted to Q2. So, this is the direction of electric force on Q1 due to Q2. From here, you can see that the direction of electric force on Q1 due to Q2 is towards Q2, or you can mention F12 with magnitude 0.01 to the right. Okay, we settle part A. Now move to the part B. Same question, but part B, they ask you to find the magnitude and direction of electric force on Q2 due to Q1. The previous question, part A, they ask you to find electric force on Q1 due to Q2. Now, it changed on Q2 due to Q1. So, same thing goes the same thing. You must do the same thing. Electric force on Q2. So, F equal to, okay, F you label with the on, since it's on Q2. So, 2, 1 on charge 2 due to charge 1. The equation is K Q2 Q1 over R21 squared. So, if you notice that the answer same with the previous one, 0.01 Newton. You make the substitution for Q2 and Q1. Also, the distance separated between them is 4 cm, and then you will get electric force on charge 2 due to Q1 is 0.01 Newton. So, that's the magnitude. So, how about the direction? So, focus on Q2. So, same focus on Q2, therefore, the direction come from Q2. So, Q2 is positive charge, the neighboring charge is negative charge. So opposite charge will attract. Therefore, on Q2, so Q2 will attracted to Q1. That's the direction of electric force on Q2 due to Q1. So, the magnitude 0.01 Newton. You can write the direction towards Q1, or you can mention 0.01 Newton to the left. The last part, part C, asks to determine the magnitude of electric force and direction of electric force for each charge. The electric force for each charge. Electric force, so some missing word here. Electric force for each charge. Okay, so here electric force for each charge, we calculate earlier. We notice we get that electric force on charge 1 due to charge 2 is 0.01 Newton. So this F electric force on charge 2 due to the charge 1 also 0.01 Newton here. So the answer electric force for each charge is 0.01 Newton. The direction, okay, based on the direction Q1 and Q2, we have done it earlier. So we know that each of the charge attracted to each other. So, meaning that the magnitude of electric force for each charge is 0.01 Newton, while the direction of electric charge for each charge is toward each other. That answer for part C. Settle example 1.1.1. Okay, we move to another example. Example 1.1.2. Okay, the given to you 3-point charges lies on the axis as shown in figure below. So you have charge 1, charge 2, and the third charge. The charge 1 is 2 Coulomb, positive charge. The charge 2 also positive charge, 4 Coulomb. Charge 3, negative charge, 6 Coulomb. Separation between Q1 and Q2 is 3 cm, while separation between Q2 and Q3 is 5 cm, and separation between charge 1 and charge 3 is 8 cm. So they ask you to calculate the magnitude and the direction of net electric force. So, to calculate the magnitude and the direction, okay, of the net electric force exert on Q2. Okay, so F net here refer to, you want to find the total or summation F. Just recall back the previous semester. Okay. So how we want to find the net electric force? Okay, focus on Q2. So here Q2 will experience electric force due to charge 1, and also Q2 will experience electric force due to charge 3. So here, if you draw the direction of electrostatic force on Q2 due to the both charges, you will find that, okay, so first we do the direction for electric force on Q2 due to Q1. Okay, look here, Q2, Q1. On Q2, so the direction of force will come from Q2. Either the force attracted to Q1 or repel or away from Q1 depends on both charges. Okay, so here, if you see here, Q2 is positive charge and Q1 also positive charge. So, same charge will repel. So, if repel, meaning that the charge will away from Q1. Okay, so the direction away meaning that avoid. So this is the direction electric force on charge 2 due to charge 1. Okay, so how about electric force due to on Q2 due to charge 3? So you look here, Q2 is positive, Q3 is negative, so opposite charge. What will happen to the on Q2? Q2 since is opposite charge, so Q2 will attracted to Q3. So when you attracted to Q3, so suppose you move toward. Okay, so that's the direction for electric force on charge 2 due to, due to the charge 3. Okay, so here how many electric forces acted on Q2? So we have 2 electric forces acted on Q2. Therefore, F net meaning you total. So how many force? Total. So you have F21 plus F23. Okay, you total that. Okay. So since both move towards Q3, or in other words, move to the right, so both here F21 and F23 both is positive. Why? Because electric force is vector, so must include the direction. Okay, so we identify the direction of electrostatic force acted on Q2 due Q1, and also the electrostatic force acted on Q2 due to Q3. This is the direction. So we want to find the net net meaning the total electrostatic force acted on Q2. So we have two electrostatic forces acted on Q2, F21 and F23. Since both directed to the right, meaning that toward the Q3, so both a positive electric force. So you make some substitution by using this equation, KQ2 Q1 over R21 square plus KQ2 Q3 over R23 square. After you make the substitution, the value, make sure all the with the SI unit, and then you will get the net is equal 1.664 10 to the power of 14 Newton direction to the right or toward the Q3. Okay, so this is the third example, but actually the question exactly same with the previous example, example 1.1.2, just you change the net electric force from on Q2. Now they ask you to calculate the net electric force on Q1. So just focus on Q1. So on Q1, you must find the net electric force. So before that, you must identify the direction of electrostatic force or electric force acted on Q1 due to Q2 and Q3. So the first one, we determine the direction of electrostatic force acted on Q1 due to Q2. So if you look here, Q1 and Q2 both have same charge, meaning that the on Q1, the Q1 since it's same charge, it will repel from Q2, meaning that you move away from Q2. So this is the direction for electric force on Q1 due to Q2. So now we go to the next charge, which is Q3. So the direction of electric force or electrostatic force on Q1 due to Q3. So first look at the charge. Q1 is positive charge while Q3 is negative charge, meaning that it's opposite charge. So Q1 will attracted to Q3. So the direction is, so this is the direction for electric force on Q1 due to Q3. So if you look here, the direction of electric force acted on Q1 a little bit different when we focus on Q2 previous example. So we have both direction, F13 move to the right, F12 move to the left. So want to find F net as usual. Net meaning that you sum up, you total up how many forces there. So you have two forces, which is F12, you plus with F13. But you must consider that since F12 directed to the left, so it is negative. Then you substitute the equation. KQ negative KQ1 Q2 over R12 square plus with KQ1 Q3 over R13 square. So I just want you to remember that I put the negative, include the negative sign here, not due to the sign notation for the charge involved. This represent the direction of F12, which is to the left. So after you substitute the value, the formula, and you substitute the value, you will find that for the F net, F12, you will get F12 is negative 8 10 the power of 13 y plus with the F13. F13 is 1.69 10 the power of 13 Newton. So here, if you sum up, you will get the answer is around negative 6.31 10 the power of 13. Sorry. And the unit is Newton. Okay. So here, we have the negative sign here. So you rewrite the answer again to express what is negative sign represent. Okay, so you write the answer 6.31 10 the power of 30 Newton. So negative here it represent the direction. Direction is to the left. So that's the answer for net electric force exerted on Q1. The magnitude is F net equal to 6.31 10 the power of 30 Newton, and the direction is to the left. Okay, so that three example that I show you just now how to solve the problem. Okay, so here is a few exercises that you can do by your own, but here you can do exercise 3. This exercise 3 a little bit different from the example that I show you. So here you must, okay, I just given you a few guidelines here. First, based on the equation, they ask you to find the net electric force on Q2. So as usual, the first thing first is you must determine the direction of electrostatic force acted on Q2. So here, Q1 and Q2 both positive. So Q2, direction of Q2 since it's same charge. So Q2 will away from Q1 because it focus on Q2. So this is F21. So how about the Q2 electrostatic on Q2 due to the Q3? So if you look here, Q2 is positive, Q3 is negative. So therefore, the Q2 will attracted to the Q3. But how you want to draw the direction of electric force? So you must remember that the direction of electric force is along the line that joining the two charge. So here, so this is the direction of electric force acted on Q2 by Q3. So in this case, you must resolve in order to find the net. You must resolve for X component and Y component. So I hope you can try it by your own. Okay. Same goes with the question 4 and also question 5. Okay, now we proceed to 1.2, which is electric field, and under this 1.2 we have 1.2a, define and use electric field strength. Okay, have you ever heard the word electric field? Do you know what is the meaning of electric field? Okay, let me tell you. Basically, electric field is a field that exists around each electrical charge, and it will exert force on all other charges in the field. Okay, so every electric charge surrounding electrical charge, it has electric field. And if other charge in that field, the other charges will experience electric force. Okay, so for definition, here you can define it as, okay, electric field is defined as the electric force or electrostatic force per unit positive test charge that act at that point and it same direction as the force, meaning that the direction of electric field or electric field strength is same direction as the electric force. For definition only, it stress for per unit positive test charge. But for exercise or calculation or problem solving, sometimes the test charge could be positive or negative. So this is definition in terms of word. So we can write in terms of equation based on this definition. So this equation E equal to F over Q naught. For definition, you can use this equation. But if you want to use this equation as a definition, then you must add, okay, you must add the meaning or the representative, the quantity that represent by each symbol. Like, okay, E is the electric field strength, you must define it. F is the electric force. Q naught, magnitude of test charge or positive test charge for definition. So you must know that the direction of electric field or electric field strength, the direction, same direction with the electrostatic force. And electric field here is a vector quantity, so it must have magnitude and also the direction. The unit of electric field is Newton per Coulomb, where you get the Newton from the unit of force and Coulomb for the unit of charge. Okay, you already know the definition of the meaning of the electric field. So now I just want to ask you how you can visualize electric field around electric charge, because surrounding every electrical charge there is electric field. So how you can visualize electric field around electric charge? Any idea? Okay, so I want to introduce to you electric field line. So electric field line is used to visualize electric field around electric charge. For example, okay, this is the positive point charge, and here the line with the arrow, the radially upward line with the arrow is electric field. So, sorry, this is electric field line. So, here is electric field line. So, electric field line here is used to represent electric field. Okay, so we can write here, label it, SE, represent electric field. Same with my right hand side. So this is the electric field that represented by the electric field line that is radially inward to the negative point charge. So the difference is for positive, the arrow is upward, while for the negative, arrow is inward. So here also the electric field line that represent electric field. So clear? Once again, electric field line is used to visualize the electric field around the electric charge. Okay? Understand? Okay. In previous slide, you have seen the pattern. You saw the pattern of the electric field around a point charge. For this slide, you will see the pattern of electric field line configuration of two charges. Okay, this is the pattern or how the electric field look like. We have two charges. One is negative charge and another one is positive charge. So this is the pattern of the positive and negatively charged particle is side by side. Okay, another one is the pattern of the two positively charged particles. So positive charge and also positive charge. This is the pattern of the electric field look like. Okay, so here I want to list down a few properties or characteristics in order to sketch of electric field line. So first one is the electric field line must begin on positive charge and end on negative charge, or at infinity as the statement here. So example here, you see that this is a positive charge. Positive charge electric field line is outward from the charge, and for the negative charge electric field inward. So they start from positive and then end with the negative. Okay, so the second property is the number of electric field line leaving a positive charge or entering a negative charge will be proportional to the magnitude of the charge. Example here, you see here we have two charges, one is negative, another one is positive. For the negative charge, the magnitude is Q. But for the positive charge, the magnitude is 3Q. 3 times greater than the negative charge, the magnitude. So here, the positive charge, the magnetic field line, so not magnetic field line, sorry, electric field line, leaving a positive charge, suppose greater compared to the electric field line that entering the negative charge due to the magnitude. So we look here. So for positive charge, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19. Okay, so from positive charge itself, the electric field line come out, leaving the positive charge here is greater compared to electric field line that entering. The entering is 1, 2, 3, 4, 5, 6. Okay, so that's why if you want to sketch or draw electric field line to represent the not magnetic field, sorry, to represent the electric field, it depends on the magnitude of the charge. The greater the magnitude, meaning that the greater number of electric field line. For the third properties, okay, the strength of field or the strength of electric field proportional to the closeness. Okay, so here, example here, you see, the example, I just put apart from the charge. So, this is the positive charge. Around the charge, we have magnetic field that represented by electric field line. So, here, if you look carefully, there is the closeness. Okay, so this part and compare for this part, I label it with part A. This is part B. So the strength of field A is greater. A is greater than B. Strength of electric field at A is greater than electric field at B. So how you know? Okay, depends on the closeness. So the spacing between the electric field line, the closer, meaning that the more strength the electric field. Properties number 4. The direction of electric field is tangent to the field line at any point in space. So here, this is the electric field line for pattern for different or unlike charges, positive and negative. If you want to determine the direction of electric field at any point in this space, so let's say at point P, so tangent to the point P is the direction of electric field at that point. Okay, point number 5, properties number 5 for electric field line is electric field line never cross. Electric field line never cross. So, what it means? Okay. So, this is positive charge. Okay. So, you compare between the two pictures. Okay. Positive charge. That is the correct electric field line that you draw to represent the electric field. So, positive, the direction of electric field line is radially outward from the point charge. And the electric field line never cross. If you see for picture my left hand side, this electric field line cross each other. This electric field line cross each other. This electric field line cross each other. So it's wrong. Understand? Okay. This is a link for a YouTube video. You can check out by your own in order to understand about electric field. So check it out. Okay. So now I want to introduce you an equation. Equation for point charge. E equal to KQ over R square. Okay, so where this equation come from? Okay, so this is the equation based on the definition of electric field. Okay, electric field equal to electric force per unit positive test charge as mentioned in the definition. So Q naught is the test charge, and then what happened is, okay, you already know the electrostatic force formula is F equal to Q naught over R square. Okay, so Q naught is test charge. We have test charge. Another one is point charge. Okay, now from here, okay, we get E equal to Q naught over R square over with the Q naught, which is Q naught over R square. Actually, if F, you substitute the F here, and then Q naught and Q naught here you can cancel out. So you come out with this one, KQ over R square, or sometimes it represent with capital Q. Okay, so Q here, this Q and this Q is represent charge for the point charge, not the test charge, because test charge already cancel the test charge, Q naught and Q naught here. Okay, so once again, you must remember that, okay, in order to calculate the value of electric field here, we just substitute the magnitude of the charge, not without include the sign of the charge. So, to determine the direction of the charge, I will show you after this. Okay, so how we want to determine the direction of electric field? Okay, so a positive isolated point charge. Let's say you have positive isolated point charge. Okay, this is the point charge. Okay, so around the charge, you have electric field that represent by electric field line here. Okay, so if there is positive test charge, okay, so if you want to determine the direction of electric force, okay, the direction depends on both sign for the positive charge, not the positive charge, sign for the point charge, here is positive, and also the sign for the test charge, here also positive. So, since same polarity or same charge, therefore the direction it will repel. So the direction of electric force here, not electric field yet, electric force. That is the direction of electric force repel on test charge. So this is the direction of electric force for this test charge. So how about the direction of electric field? So electric field, the direction of electric field, remember that just depends on the point charge. Okay, so if the point charge here, the point charge is direct, for point charge that positive, the electric field line is outward here. So the direction of E, direction same with the electric field for the point charge which is positive. So let's see how about if the point charge is negative. So this is negative point charge. So electric field that represented by the electric field line, the direction of electric field is directed inward. Okay, so if we have positive test charge, okay, so in order to determine the direction of electric force, once again, electric force, it depends, the direction depends on sign for the test charge and also the sign for the point charge. So here, unlike charge, different charge, positive and negative. So suppose it test charge here attracted to the, we call this one is point charge. So the direction is, that is the direction of electric force if the test charge is positive while point charge is negative. So how about the direction of electric field? So the direction of electric field depends on the direction of electric field on point charge. So since negative, so this is the direction of electric field point charge. Okay, so let's say if here we change it, the test charge, if I mention if the test charge is negative, Q naught negative. So what happens if I want to determine the direction of electric field? So since it depends on the point charge only, point charge is positive, so even though the test charge is negative, the direction of electric field also here. But the direction of F, positive, negative, attracted. So you see here, the direction of F depends on both. Depends on test charge and also point charge. Okay. But direction of electric field only depends on the point charge. Even though the test charge actually is to the negative test charge, the direction of electric field same as the previous when we use the test charge is positive because we don't change the point charge. Okay. Okay, so we look a few examples here. So example 1.2.1 under electric field. So they ask you to calculate the electric field strength. So electric field strength same with the electric field, which is electric field strength at point A, located 2 cm from a point charge. This is the point charge labeled with the Q1 and the magnitude is 5 microcoulomb. Given to you for part A, they mentioned that if Q1 is positive charge, what is the electric field strength? And also for part B, If Q1 is negative charge, what is the electric field strength? Okay, so what is the formula? So we have two equations here. We have two equations. Okay, so you have learned about this equation. E equal to 1 is F over Q naught. Okay, from definition. And also E equal to KQ over R square. So, the equation, this is the equation that we will use regarding to the question. Okay, so what happened now is, we mentioned to you, we settle for the part A first. If Q1 is positive charge, so Q1 is positive charge, this is the positive charge. So you must know what is the direction of electric field line for the positive charge. Positive charge, electric field line is directed, pointed radially outward. Okay, like this. Okay. So, I mentioned earlier that the electric field strength or electric field, which is E, the direction depends on the direction of electric field at the point charge. So, at point charge here, this is the electric field at point charge. So, this is point A. So, the direction of point, so the direction of E at point A. Okay. So, this is the direction E at point A if point charge is positive. So, that's the direction. Why I ask you to determine the direction? Because electric field is a vector. You must have the magnitude. So, how we get the magnitude? Use this equation to calculate the magnitude. And the direction, how to determine the direction? I just show to you how to determine the direction. So, A, formula E equal to K, Q, doesn't matter, you can use capital Q or small q as long as you know that Q represent the magnitude of the point charge, not the charge, up to you. Okay, K is 9, 10 to the power of 9. Remember that. And then Q, 5 micro. Micro is 10 to the power of negative 6. And R is change it into into meter. So 0.02 square, y square, because the equation is square. And then you will get the value, the magnitude of E is, okay, that's the magnitude of E. So, not clear. So, E here is, okay, I just, the magnitude of Q, okay. Okay, so I just wrap, okay. So, you substitute the value without the sign, and then you will get the answer for electric field at A is 1.12125. Okay, value you substitute 125, and then you get there is the magnitude. Okay, and this is the direction. How you know the direction? This the direction. This part. The direction is away from point charge Q1. Okay, so for part B, part A is settled. If Q1 is positive, okay, settle. Now we deal with the part B. Okay, all the same except the point charge, either is positive charge or negative charge. So now for part B is negative charge. So you draw the direction of electric field, isolated charge for the point charge, negative charge. So negative charge, the direction of E is, what I'm doing now, I'm sketch the direction of electric field line. This is the direction of E for the point charge, negative point charge. Okay, so inward. So point A, direction of electric field at point A depends on the point charge here. The direction of electric field at point A depends on the point charge, not depends at the point A itself. Okay, depends on the point charge here, the direction. So this is the direction inward. Therefore, I use another color. So this is the direction of E at point A if the point charge is negative point charge. Okay, so you calculate the magnetic direction towards the Q1. So magnitude, okay, KQ over R squared. You substitute the value of K and then the magnitude of Q1, which is 5 microcoulomb without the sign, even though it's negative charge, and then you will get the answer. Same with the previous one, because we don't change the magnitude of the point charge and also the separation between point A and the point charge, but we just change the direction. We just change the charge for the point charge, positive and negative. So the direction of the electric field at point A when the point charge is negative is towards point charge Q1. Okay, now we move to another example, 1.2.2. So here the given to you 2 point charges. Q1 is positive charge, Q2 is negative charge, and then the magnitude of Q1 is 1 coulomb while Q2 is negative 4 coulomb. Place 2 cm from the point A and 3 cm point A from Q2. Okay, so they ask you to find the magnitude and direction of electric field intensity at point A and also the resultant electric force F exerted on Q not 4 coulomb if it is placed at point A. Okay, so solution, how to solve this equation, this type of equation. So solution. Okay, so first, you look at point A in order to determine the direction electric field at point A. So meaning here, at point A, we have two electric field experienced by point A due to point charge Q1 and point charge Q2. So we look here that since it's positive, so if you cannot remember how to, you can sketch electric field at point charge. For the positive charge is upward. So then at point A, electric field depends on point charge Q1A first. So this is the direction of EA1. Electric field at point A due to the point charge 1. So for for Q2 is negative. So if negative, so you just sketch electric field line. you cannot. Okay, electric field here inward for negative charge. So this point charge is negative. So you look here. Sorry. The arrow. So electric field at point A due to negative charge. So this is the E A due to point charge 2. Okay, so how direction, magnitude and direction. So here electric field intensity at point A, since we clearly see here, we saw here that we have two electric field at point A. So therefore, actually you find they ask you to find the total electric field at point A. So total electric at point A. So formula says the E total sum E at point A equal to E A1 is total sum plus E A2. Since both EA1 and EA2 directed to the right, so both is positive. So here your task is to find EA1 equal to K Q. I use this small q. Q1 over with RA1 square. So Q1, you substitute the Q1 and R, you will get around 2.25 Newton Coulomb, while for E2, EA2, if you use the formula and you substitute KQ2 over RA2 square, you will get answer is 413 Newton Coulomb negative 1. So by using this value, this one and this one, to answer here, so 2.25 10 to the power of 13 plus, since both to the right is positive, 4.0 10 to the power of 13, then the answer is equal to 6.25 power of 13 Newton Coulomb negative 1, and the direction is towards Q2, towards Q2 or to the right. Okay, we settled part A. Now move to example part B. Example part B asks you to find the resultant electric force exerted on test charge 4 Coulomb if it is placed at the point A. Okay, the previous example, at point A is just a point. Now, at this point, point A, replaced by the test charge magnitude for Coulomb. Okay, so now at point A, you have test charge and then it positive test charge. Magnitude is 4 Coulomb. Okay, so they ask you to find the resultant electric force. So you have this formula E equal to F over Q naught. Okay, so Q naught here is the value of 4 Coulomb. Okay, now F here is the resultant electric field. So E here must be E resultant also, or E net or E total. But for this E, we already find it earlier in part A that E resultant and E total we represented by the E at point A. Okay, remember? Okay, so from this one, you rearrange the equation, you will have F equal to E Q naught. So E is equal to 6.25 10 to the power of 13 multiply with the test charge 4 Coulomb and you will get the answer. So the answer here is 2.5 Newton. So that's the magnitude. So how about the direction? So how you want to determine the direction of F net? Okay, the direction of E net, the previous, based on definition, the resultant of E electric field same with the direction of F. So since we have already know the direction of E net, so therefore we can find the direction of F net. But remember, the direction of E net for part A is toward Q2. So EA at point A is towards Q2. So F net the direction is also towards the Q2 charge. Okay, so this direction of EA is due to the part A, which is you sum EA1 plus EA2. Okay, so E net for this one is towards Q2. Therefore, direction of F net at point A due to the 4 Coulomb charge also towards the Q2. Okay, so that's for the learning outcome 1.2 and 1. 1.1 and 1.2, which cover lesson 1. So here are exercises. There are a few questions that you can do it by your own, but to do your tutorial first that related to the subtopic 1.1 and 1.2. So there are also exercises that you can do. Okay, so that's all for lesson 1, and we proceed to lesson 2 for the next class. Okay, thank you.